Hello everyone, this is assignment 4, and if I'm not mistaken, it's the last assignment for this class, at least in the summer term. There's MATLAB, sorry, there may possibly be assignment number 5, but we'll get to that when we do. I will be uploading MATLAB number 5 as soon as I can. I have 2 other uploads regarding coding that I got to get to. And other than that, I have done my due diligence because I was quite busy today. I wrote out all of the assignment in LaTeX, so it's very clear and very straightforward of what we're doing. I did this for question 1 through 5, and I will personally go through 6, 7, how many questions are there? I think it's up to 9. Yeah. So I will go through 6, 7, 8, 9. This will be a little bit. I did this because of the content in this assignment. It's quite long and tedious. But yeah. So with the first question, they present you, and I always have this kind of like recognize part because you really want to understand what type of question you're doing. So the question tells us to use variation parameters. So instantly you zero off and you plug in your m, you isolate, and you'll get the repeated imaginary root. We're told to do this with variation parameters. So we know that our complementary looks something like this. We do our Wronskian, so 1, 2, 3. Then we get our W, our U1 and U2. We perform a U sub, and I will have this document with a watermark in the description. If you guys need me to go over anything in detail more, just feel free to DM me as usual, or find me on the internet. So yeah, then we can kind of continue with each one. We have our U1 and U2. We continue with U2. And then we just plug it back into our equation. So our y particular is as follows after you multiply everything out. Okay, and I'm just gonna, as I go through these, I'm gonna double check to make sure that everything I have there is what aligns with my answers. And it is as of yet. Okay, so then we have the repeated real roots, but these are real. So we do our complementary, we find our m. You'll notice a pattern. We're going to do our Wronskian once again. And then after we do our Wronskian, then we're going to do our U sub for U. We're told once again in this variation of parameters for the second question. And then we have to do a trig sub. So we isolate for our dx. And we do our trig sub as such. So we want to put it into a form such that we can use our trig sub. And then we're going to end up, after, we're going to get 81 in the denominator. So this will be squared, right? So squared right here. So we'll have 81, and then the secant squared will cancel out. I have this should just be secant. This shouldn't be secant squared. So let me cross that out. So just be secant theta, and then you square it, and it gets canceled out. And yeah, that's about it. On to the third one, and then yeah, you just plug it back into your particular equation. So on to the third one, we have a Cauchy-Euler, or if that's however you pronounce it. We're going to sub in our guest solution, our guest solution. Then we have this is like a shortcut that we use. It's if you've gone to the lectures, you'll recognize it, but it's basically if you see the initial equation something like in this form, you can immediately get to your m, like your only m equation, very fast by using this. In this case, it was 1, and then you have 11 minus 1, so then we had 10m, and then we had 41. And then we factored, sorry, not factored it. We isolated for m, we solved for our roots, and we got this. So we plug it into our following equation for the Cauchy-Euler type problem. And then you isolate for C1 and C2. So as usual, you're going to take the derivative. Let me see for this question. This is question number 3. Yeah, so you're going to take the derivative and then, yeah, sub in as you should to solve for C. This is, at this point, we've done this for a couple assignments now. It's not... If you don't know what I'm talking about, review sort of assignment 4. No, so this is assignment 4. Assignment 3, assignment 2, and you'll get the deal. And then, yeah, so then we get our y is this. So continuing on, this is another Cauchy-Euler because we recognize the x squared and the second order or above like ordered derivative. And so we take our guessed derivative as necessary. We see that we have m as a multiplicity of 2, and we have m equals 7 on the side. So we know that, like, for Cauchy-Euler, if you have a repeated one, you don't end up multiplying by x. No, I should put this in a separate question. You end up multiplying by ln x. This is what you should do for Cauchy-Euler. And then we have x to the 7 on the side. And we do a little bit of work, and we isolate for our c's. And then we back substitute to solve for each of them. And then we'll get this. Now on to question number 5. We also know that this is a Cauchy-Euler. This time around, they didn't give us any initial conditions, but they tell us to solve with variation of parameters. And so that's what we're going to do. So as usual, we zero off and we solve for our roots. This is what our complementary solution looks like. We do our Wronskians. We do our U1, and then U2. Sorry, I think, yeah, this should be U2. Sorry about that. U2, and then, yeah, then we cancel as necessary after we multiply. So like this would be x squared in the numerator. And then, yeah, that's our solution. That's all I have for question 1 through 5. Now let's do question 6. Okay. Long day, guys, long day. So I'm going to find my solution quickly. Question 6, I think it was, no, question 6 wasn't bad. It was question 5, question 7, which was the real problem. Just give me a second to pull my solution up so I don't guide you guys incorrectly. Okay, cool. So, let's start down here. Let's go green. So for these types of questions, you need to know a very important formula, which is m d2x over dt squared plus beta dx by dt plus kx equals 0. So the mass is this one. And then your constant, or sorry, not the constant, but how much it stretches via the weight is what you put for beta. And in this case, they tell us that the weight hangs vertically from the spring and a damping force numerically equal to 9/2 root 10 times the instantaneous velocity acts on the system. And so writing down what we know that, initially, just with the weight on it, it's stretching to 20 feet. So x at 0 equals 20. B, how much it's stretched, equals 20. Okay. Our m equals 180 pounds. And so then we continue reading the question, and we see that the weight is released from 10 feet above the equilibrium position with a downward velocity of 43 feet per second. So we could say that x prime at 0 equals 43. And then also our x equals negative 10. The reason why it's negative 10 is if this is our equilibrium position and downward is positive, then if we're stretching this thing upwards, it's negative 10, given our reference frame. So yeah, so then we're going to continue on with the question. So, okay, so we know that our weight equals mass times gravity. In these questions, you have to do some stupid shit with gravity equals 32 slugs or whatever. Just do it. Like that's just something you have to like be used to at this point. I know we're used to 9.8, but for the sake of the question and for the sake of this class moving forward, this is what you have to convert to, given the units that he gave us. And so we solve for our mass by doing our weight, which is 180. Sorry, I wrote down, I think here, 180. This is our weight. So we do 180 over 32 equals 5.625. So our equation looks more like 5.625 d2x over dt squared plus 9 root 10 dx by dt over 2 plus 9x equals 0. And yeah, so then we're just going to kind of continue on with this question. So now we have more so like a auxiliary type of question. And so now we can do 5.625 m squared plus 9 root 10 over 2m plus 9 equals 0. Now you solve this and you'll get m equals negative 2 root 10 over 5. Cool. And this has because it's second order, it has a multiplicity of 2. And so then we get x at t equals c1e to the negative 2 root 10 over 5t plus ct e to the negative 2 root 10 over 5t times t. And so we use our initial condition, which is for this case, which is x at t, we're going to say that x at 0 equals 20. And so after we plug everything in, then we'll get C1 equals, sorry. If x equals negative 10, right? Then after we plug this in, right, we should get C1 equals negative 10. This is because, yes, x at 0 equals 20, but we're considering only from like we're considering only from where it's released from. So like we care about where it moved and not necessarily initially how it was, at least for the sake of this question. Okay, so then we're going to take the derivative of this question, or the derivative of this problem. So x prime at t equals negative 2 root 10 over 5 c1 e to negative 2 root 10 over 5t plus c2 e to negative 2 root 10 over 5t times t. And then we'll have negative 2 root 10 over 5 cte. Oh, I could just copy paste the rest. Cool. Yeah. Okay, cool. So now we plug in our velocity initial condition. So 43 equals negative 2 root 10 c1 over 5 plus c2. And we get 43 equals 4 root 10 plus c2, and c2 equals 43 minus 4 root 10. Cool. Now, once we plug our conditions, our c's into our initial equation, we're going to get y equals negative 10 e to the negative 2 root 10 over 5t plus 43 minus 4 root 10 e to the negative 2 root 10 over 5t times t. And we want, for this question, when it passes through the equilibrium position. And so we're going to say that x at t equals 0, and we're going to solve for the time. Now, the reason why we set this condition, how we kind of, or t naught, is because, well, we're looking for a time, and when it passes through the equilibrium position, we're looking for, usually when we set this, you could consider this, x at 0 equals negative 10, right? Let me get rid of this. Incorrect. Don't worry about that. I think I wrote that down and I initially got rid of it afterwards. So if x at 0 equals negative 10, we're measuring the distance from the equilibrium position. So when it's at the equilibrium position, then it's 0 away from the equilibrium position. And so we're just kind of solving for t at this point. And so if that's the case, then we'll get 0 equals negative 10 plus 43t minus 4 root 10 t e to the negative 2 root 10 over 5t. Now, this right here, equal to that, has no solution. We know that at this point. It's like e to the x equals 0, and you'll try to ln 0, and you know what happens at that point. And so we only really get 43t minus 4 root 10 equals 10t, sorry. And then we isolate for t equals 10 over 43 minus 4 root 10 equals 0.3295, which is correct. And then solving for b, which is the mass attains extreme displacement. Okay. Then we get, so we have what's it called? We have an equation now where, let me see where it was. Yeah, so we have this. So this models our displacement. We're looking for extreme displacement at this point. And so we're looking for a point, how do I say? We're looking for a point in the, that's a horrible graph. So let's just say like this is our v at t, right? Let's just say this was a ball, and I threw this up. It has the most, it has its greatest velocity and is the furthest away when the slope of it, right, when x prime at t equals 0 and x prime at t equals v at t, right? So that's how I rationed it. And so that would tell me when I have when it's the farthest away from my position. We're not really considering points like this because this isn't a ball. This is more so a damp, right? Like an oscillator. So it's furthest away from here, and let's just say that like this is what it is. Then this is when it's the farthest away, and then it'll start coming back up. So that's another way to picture it. But basically, all I'm going to be doing is just taking the derivative of my initial equation and then subbing in t and solving for t again. So what I'll have then is, just to restate my original equation, is x at t equals negative 10 plus 43 minus 4 root 10 multiplied by t e to the negative 2 root 10 over 5t. So x prime at t, you can do, I won't go into the details of this because a lot of this assignment I actually use like the what's it called, derivative calculator, just to be like sure of it and to not spend a million years trying to write out the entire derivative. We will probably have pretty complex derivatives on the exam. I don't take that away, but at that point in time, I'm gonna hope your skills are pretty good at this point. So, -2 root 10 over 5, and -10, plus 43 minus 4 root 10 t, okay, plus 43 minus 4 root 10. You might ask what we did with this portion right here. We just got rid of it because we know there's going to be no solution to it regardless, and so it won't affect our final answer. You can keep it for sure, but you won't benefit anything from keeping, because you end up just factoring out and seeing that it won't have any solutions. So continuing on, we have 0 equals 4 root 10 minus 2 root 10 times 43t over 5 plus 4 root 10 times 2 root 10 over 5t plus 43 minus 4 root 10. Okay, cool. And so then we're going to simplify. We see that this and this cancel out, and you're going to add these two up and then be left with 40. What was my initial condition? This is, oh yeah, we're on question 6 right now. Okay, so yeah, so we're at 43, and then we get 0 equals 80 minus 86 root 10 over 5t plus 43. Okay? And so then we get negative 43 equals 80 minus 86 root 10 over 5t. After we isolate, we get t equals negative 43 times 5 over 80 minus 86 root 10. And this equals 1.1200. Cool. So that's problem number 6. Problem number 7. And this question took me a long time to get from what, yeah, this question took me. You could hear me flipping through the pages. I spent a good deal of my time on this question. Wait. Yeah, this question. Okay. Let's see what we got here. Certainly not 7. 1 second, let me find my solution to this. Okay. So, we know that our m equals 5 because they say 5 kilogram mass. Our spring constant equals 20 newtons per meter. And we know that x at 0 equals 0 and x prime at 0 equals 0. How do we know that? It comes to rest in the equilibrium position. And it's saying kind of two things in that. It's coming to rest in the equilibrium position. So x at the equilibrium position, which is 0, equals 0. And then also, because we know that it comes to rest at the equilibrium position and it starts at t equals 0, then it is 0 at when it starts out. And we know that f at t equals 15 e to the negative 4t times cos 7t. And so we construct our, you can write it like this. So m d2x over dt squared plus k times dx by dt equals f at t. You can write it like this for sure. I like to write it like, well, I'm going to sub in and write it how I like to write it. So 5x double prime plus 20x equals, and I'm going to copy and paste this. Cool. And so skipping a little bit, you zero off, you solve for your m value, and you'll get m equals plus or minus 2i. So we have no real value, no real part to this. And so our complementary solution is c1 cos 2t plus c2 sine 2t. The really annoying part about this question is that you have, like, this is your how to say, auxiliary equation, and you need to consider this part right here. You know that because you've done undetermined coefficients at this point, and there's no lns present, so that's what we're going to do. Calculating the derivatives for this is very annoying. I am going to write down what's necessary. Please know that, like, I tried to do this by hand a few times, and it's just so annoying, and it's not worthy of your time, at least right now, for the sake of the video. And so this is what you'll get after you put this into some software, and I'm writing it exactly like how they write it. Sine 7t, and then we have plus 56b plus 33a cos 7t. Cool. So you know that you're going to plug this in. So I'm gonna give you guys a little bit right here. So we plug this in here, and then we plug this part in here, and we set it equal to this, okay? And so just, if you do that, you'll follow along with me, and you'll see that you'll get something like 145a plus 280b equals negative 15, and 280a equals 145b. This part is for sine, this part is for cos. So do with that as you will. Yeah, you're just gonna kind of isolate and then plug back in. You'll get b equals negative 168 over 3,977, and you'll get a equals negative 87 over 3,977. If you don't get something with the same denominator or something similar, you most likely messed up somewhere. So keep that in mind. Okay, then you're going to plug your particular solution back into your original one. So I'm going to copy paste this. I have it as y now, but like I'll change it. Here you go, guys. So we have x equals, and then we get plus negative 87 over 3,977 cos 7t minus 168 over 3,977. I'm going to make this smaller. Sine 7t e to the negative 4t. Okay, and then 0 equals c1 minus 87 over 3,977, and you'll get c1 equals 87 over 3,977. Then you'll get, so you need to, what's it called? You'll need to, like, when you're solving for c's, you have to take the derivative, and we also know that we have to take the derivative because we are given this sweet little piece of information, and we know that we're going to have to eventually use that. And so a little bit more work, and you get negative 2c1 sine 2t plus 2c2 cos 2t minus 4e to the negative 4t negative 87 over 3977 cos 7t minus 168 over 3977 sine 7t. And then we add the other portion, 7 sine 7t times 87 over 3977 minus 7 cos 7t times 168 over 3977 times negative 4t, e to the negative 4t. So we isolate 2c2 plus 4 times 87 over 3977 minus 7 times 168 over 3977, and c2 equals 414 over 3977. And you plug your c1 and c2 back into this equation, and you will be just fine. Okay, now on to question number 8 and 9. Okay, this question is difficult to say the least. Oh, I skipped past a little bit of work for 7. Okay, so we have the equation, right? I just realized I had more written down. I didn't even continue it. So we have x at t equals 87 over 3977 times cos 2t plus 414 over 3977 times sine 2t plus negative 87 over 3977 cos 7t minus 168 over 3977 sine 7t e to the negative 4t. Okay, and they say find x at t when t equals pi. So basically x at pi equals what? And when you plug that in, you'll get 87 over 3977 plus 87 over 3977 equals 174 over 3977. And then this will end up being 0.0219, which is correct. And the amplitude at a long time, this is an equation given to us in the lecture slides at let's just find like that. A long time, or after a very long time, / after long time, is a equals the root of c1 squared plus c2 squared equals 87 over 3977 squared plus 414 over 3977 squared equals 0.1064. Cool. And that is question number 7. Okay, question number 8. I did not like this question for a couple of reasons. The prof really didn't go into much detail on doing a question like this, but I will try and walk you through the best I can. So, this is mine. And these are our initial conditions. So we know that we're not taking any derivatives here. They tell us that you can take C1 or C2 as 1. Okay. So I'm going to use my special equation plus b minus am plus c equals 0. We get m squared minus 18m plus 81 plus lambda equals 0. Now, you can go ahead and plug this into the quadratic equation, but we can also just focus on the discriminant, which is b squared minus 4ac, and b is 18, and so we'll get 324 minus 4 times 81 plus lambda. Remember, a is 1 in this case, so we're just worried about c. And then we'll get 324 minus 324 minus 4 lambda. You can tell what's going to happen here. We're going to get negative 4 lambda. Okay. I want real roots. Okay. And for that, I need negative 4 lambda to be greater than 0. When we divide by negative, the sign switches. And so I need lambda to be less than 0. This should tell you what case we are using. Okay? So that's about all I need over there. This is to recognize the case. Now, to get my roots, right, we're going to continue with the quadratic equation. I just told you guys you don't need to worry about the roots right now because I wanted to get you guys to notice this is the type of question that we're going to have to do. And there's 3 question types. Like, it's been repetitive in this course when it comes to quadratic, positive, repeated real roots, and then imaginary. Okay, so for m, I get 9 plus or minus li, and yeah, so I got about this far in my solution. Now, yc, going off what we know, is x to the negative 9 c1 times cos lambda, which is the imaginary part, right? The coefficient of the imaginary part, ln x plus, and c2 equals 1 in this case, okay? Plus sine lambda ln x. Okay. So when we say that y at 1 equals 0, then what we do is we set 0 equals the x becomes 1, right? And we get c1 equals 0. Okay, cool. So then what we get is yc equals x to the negative 9 sine lambda ln x. Okay. This is where things start getting a little bit funky. Okay. So what I'm going to do here is I'm going to preface this by saying for some reason I don't know, okay? X to the negative 9 is not right. When I put it in on Child's Math, it said negative 9 is wrong. I put the same, I'm going to continue the question, but I put the same thing in with a positive 9 and it gave it to me correct. I don't know what happens where the 9 switches to become positive, but I'm going to continue to show you how to do this question, given that. Okay? So, we're going to go for the second one. Like, we're going to continue on with this. And we want to solve for lambda. We can't put lambda in. This question says enter your answer as a symbolic function of x and n. And so what we do here is we want sine of lambda ln x equals 0. Okay? And at this point in time, I think that I'm not sure if there's a different way to put in your answer, but like, okay, you can shove in, you don't even have to use one of the initial conditions throughout the whole question. You could shove in y at 1 again. And okay, I'm not going to lie, at this point in time, the question gets really fucked up. If someone can explain this to me, then by all means, but like, bear with me. So you got lambda sine of lambda equals 0, and then lambda equals sine of negative, so arc sine of 0, and you get lambda equals n pi. Okay? So the n pi thing I recognize. So this part I recognize. Okay, this was in the lectures. But like from here to here is like what the fuck? I like that part. If someone can explain this chunk to me, then bless up. But yeah, the final solution equals x to the 9. I don't know why this changes. Don't know why it changes. But like, I want to give you guys the answers at this point because it's due tomorrow. And then sine n pi ln x. And then that's it. So if you follow the same structure, you'll get the correct answer. I know a lot of you guys want to see like, and I promise full solutions. I will try and review this after I like talk to the prof about it. But yeah, let's go on to question number 9. Okay, so we have our initial equation, d4y over dx to the 4 equals wx. And they say find y at x, where wx is equal to the constant value of 25. Okay, so they're saying this equals 25. I want to find y at x in this case. And so just from like Calc 2, integrate. Just keep on integrating and adding those c's. Okay? So let's just do that. We're going to have 4 d to the y3 dx cubed equals 25x plus c1. 4 d2y over dx squared equals 25x squared over 2 plus c1x plus c2. 4 dy over dx equals 25x cubed over 6 plus c1 x squared over 2 plus c2x plus c3. 4y equals 25 over 24 x to the 4 plus c1 x cubed over 6 plus c2 x squared over 2 plus c3x plus c4. Okay, and our boundary conditions, right? So they're saying that it's embedded on the left at x equals 0 and simply supported on the right at x equals 1. So I'm going to quickly check how he drew this because I think a visual diagram could help here. Just give me a second to pull up how our prof drew simply supported, because embedded I understand, but simply supported I will need. Okay, so 3.9, and he has, okay, so this is what we're saying. We have embedded, which is like, let me do this actually. So we have this, this, right? And then we have a little triangle right here, and this, I'll draw in a different color. This is kind of what we have. So it's simply supported. And they're saying that on the right, at x equals 1, okay, and then on the left, x equals 0. Okay, so we imagine that we have our y and x-axis going through here. And so we can come to a few different conclusions. So let me write this down. I wrote it down nicely somewhere. Hold on. Okay, so y at 0 equals 0, y at 1 equals 0, y prime at 0 equals 0, and y double prime at 1 equals 0. It's not moving at all, right? Okay, so we have this, I'll cancel this and make this 1 over 4. And yeah, so we have our y at x, and we just need to take the double derivative and then kind of back substitute. So taking the first derivative, you could use software for this. 25 over 6x cubed plus c1 over 2x squared plus c2x plus c3 1 over 4 y double prime at x equals 25 over 2 x squared plus c1x plus c2 times 1 over 4. So we use our initial conditions and we'll get c4 equals 0. And you'll then get, so that's for the first one. Remember, 1 over 4, when you set these equal to 0, will always just disappear, so it becomes a lot easier to manage. Then we'll get for the, hold on. Okay, yeah, so we'll get that for the first one. Then for the second one, we'll get 0 equals C3. So this one would correspond to here, right? And then for the third one, we'll get 0 equals 25 over 2 plus C1 plus C2. So C1 equals negative 25 over 2 minus C2. So we're going to sub this in back to one of the initial equations, which was when we solved for C4. Okay. And this, when we solve for C4, we're more looking for, okay. I'll put it like this. It's easier. Because I didn't write it down because I didn't want to, but like, so this one's for y at 0 equals 0. Okay. Now, what I'm going to write, and then this one's also for y prime at 0 equals 0, okay? And then this one is for y double prime at 1 equals 0. Now, I'm going to write down y prime, I'm going to write down y at 1 equals 0, what this equals. So this equals 0, 25 over 24 plus c1 over 6 plus c2 over 2 plus C3 plus C4. We know that both of these are 0, so it doesn't matter. Now we're going to substitute C1 in, right? 25 over 24 minus 25 over 12 minus C2 over 6 plus C2 over 2. And you'll get something along the lines of C2 over 3 equals 25 over 24. Now C2 equals 25 over 8. And now finally, we get y at x equals 25 over 24, x to the 4 minus 125 over 48 times x to the cubed plus 25 over 16 x squared times y over 4. And you might be wondering, where did we get this one? This is from, so we solved for C2. Yeah, we solved for C2, so we got 25 over 8, and then in the initial equation, we have, where's the initial one? Yeah, we're just plugging it in to here. So you notice that we have 1 over 6 times C1, and if I solve for C2, then C1 equals, what is it? Where did I solve for it? Negative 125 over 8. And so 8 times 6, and we get 48. And yeah, the rest, the C3 and C4 equals 0. And yeah, that's where we get this. So that's the end of assignment 4, I believe. Yeah. I will hopefully be looking to upload a video for MATLAB 5 soon. I gotta get to sleep. And yeah, hope you guys enjoyed this or benefit from it. See you in the next one.